everyone, my name is Karuna Singh and welcome to the channel Knowledge Star Continuous Knowledge Excellence. In this video, we will get to know about Cu Nanoparticle based visual detection of heavy metal ions, PBCD, Now, our expert Professor Himadri B, Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Delhi Tiger Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, and biophysics. We'll explain you in detail about this topic. So to get complete information, watch full video without skip.
This is a copper nanoparticle. Okay. Let's see what happens. You have a copper nanoparticle there. I'll tell you about the synthesis later. This is coated with a surfactant, SDS. Very standard surfactant, sodium diacetyl sulfate. So this makes a standard copper brown color dispersion in water. Now, when you add any of these materials like mercury to this thing, mercury ions, they selectively bind to the surfactant molecule and leaving the copper metal ion or nanoparticle completely exposed. And that turns the solution from brown to milky white solution. This again indicates that the presence of mercury in the solution is ensured because there's a decoloration. It's basically a catalytic action that is taking place inside it. We'll see it later. And interestingly, this was also developed into a very nice paper strip. You dip it in a mercury-containing solution, and the paper strip will get decolored to this from yellow to almost no color. Okay, so this is the synthesis of copper nanoparticles. You take the precursor, it's copper sulfate at a particular concentration, is mentioned here. Okay, now mix it properly, then you add sodium diacetyl sulfate, the SDS surfactant there, with certain concentration that is mentioned here. Raise it to higher temperature, add sodium hydroxide. Now your precursor solution is ready, pH is already basic. Add a reducing agent, hydrogen, N2H5OH, hydrogen hydrate. Now your precursor will get reduced to nano copper gradually over a period of time. And this solution color from almost transparent to change into a dark red, deep red dispersion, which will mean that your material has been converted now into nano copper. Now, when you are doing this thing, recall how I told about the Michael Faraday's experiment in 1856. He exactly followed the same methodology, or we are following his methodology. He took a gold precursor. We are taking a copper precursor here. Dissolved in water, same thing he also did. We are using SDS here, basically to keep the nanoparticles separated after they are synthesized. Then make it basic NaOH. In his experiment also NaOH was added, made it basic. He used glucose as the reducing agent and the capping agent. We are using hydrogen hydrate as the reducing agent, as SDS as the capping agent. But this rest of these things, or the philosophy of the entire thing, is parallel to what Michael Faraday proposed in 1856. We are following exactly the same protocol. Minor changes here and there. Okay, after this is formed, then you take the UV visual spectra. There is 580 nanometer. There is a peak, characteristic peak here, and this is how it looks like.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in where you can easily enroll in the workshops. So just check it out right now.
Nano copper. Temperature and the typical size about 7 nanometer. Now, this solution, the nanoparticle copper solution dispersion, is added to various concentration. To this, we add various concentration of lead to this thing. And you see what happens. 580 we had the absorption peak. It is 0, no lead, no mercury. And then when you increase the concentration of the mercury from this all ppm not ppm. This is value in 10 to the power minus 4 micromolar. Sorry, it's written here. You can see this here. 10 to the power minus 2 micromolar. So the different concentration of this, with the increasing concentration, you see the absorbance is decreasing like this. And if you plot the absorbance at 580 with the concentration of mercury, then you see almost a linearly it is decreasing. Okay, it's monotonously decreasing with concentration. It's reflective of this information. Now, what is happening if you look at the size of this particle in the presence of mercury treatment, with the particle size which was something like 20-30 nanometer earlier here in the aggregated stage, now it turns to 200 or 300 nanometer size, somewhere here, or 300 nanometer, compared to here about 30 nanometer or so. So 10 times more increase. So this is provoked by the presence of mercury there. Okay, now, interestingly, the same story repeats even for cadmium and lead. This is for cadmium, this is for lead. Again, it's decrease in this absorbance, decrease in the absorbance. So for three metal ions, copper works excellent, mercury, cadmium, and lead, it shows concentration dependence, absorption, suppression in case of all these three analytes. Now, if you look at the color of this thing, you see that different analytes are now mixed to this dispersion of the nanocopper solution. In case of lead, you look at this arrow here, transparent, no color. Mercury, no color. Cadmium, very, very faint color there. Compared to others, you see, this is the starting material. We started this and then we added different analytes, and this is the change in color. Iron, dark color. Nickel, dark color. Cobalt also is very dark color. Manganese showing some faint color, but it's not transparent. Chromium, zinc also same family. Strontium also same family. So clearly, lead and mercury are distinctively visible as metals that have been heavy metals that have been detected. And to some extent, cadmium, the same story applies. All others show a strong color, which means that they are not detected here. The detected metal ions are these three, Pb, Hg, and Cd. Now, that solution now, copper nanoparticle dispersion is put on the paper film. This is the black paper film. It gives this color. And make a paper strip out of it. Now we dip it in different concentrations of Hg solution, 10 micromolar to going to 1 millimolar. And you see the color change. So this is a clear case of colorimetric detection of mercury ion. We saw the UV visible signal support earlier, but this is now a clear visibility of the change in color to the naked eye. So this is what is called the nano eye detection of the analyte. You have copper nanoparticles coated with SDS surfactant. Now you are detecting mercury ions by dipping the strip that has coated with copper nanoions, and you see the color change, and consequently you are able to detect or sense mercury in the analyte solution. So this is as simple as this. Okay, this is basically a summary of what we've said already. It's the beautiful part of this is the development of the strip sensor from there, which is low cost, easy detection, and very, very handy. It can be used anywhere in the field trials.
I hope you liked this video. Here, I would like to give you an important information that Nanoscience and Technology Consortium, or NSTC, organized the nanotechnology workshops on interesting topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. Okay, one more thing. Do you want full recording of this previous video which you have just seen? Yes? Okay, then contact us at info@nstc.in. Further, to enroll in the upcoming workshops, you can go to the website www.nanoschool.in. So that's all. If you want to see these type of videos, then please do comment. We will definitely reach out to you. And yes, subscribe to the channel Knowledge Star. Hit the bell icon to never ever miss an update. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.